Today, we will take a look at top 5 design patterns every software developer should know. Singleton Pattern. The Singleton pattern restricts the instantiation of a class to just one instance, this ensuring there is only a single instance of the class in a system. This pattern is often applied when you want to control access to a shared resource or when a single point of control or coordination is needed. Common examples are managing database connections, logging, and caching. To implement a Singleton pattern, the most common approaches are declaring a private constructor which prevents it from being instantiated by other objects, then providing a static method that returns a reference to that instance. Factory pattern. The factory pattern provides an interface for creating objects in a superclasses, but allows subclasses to alter the type of objects that will be created. It is used to abstract the process of object creation and promotes loose coupling between client code and the objects being created. The factory pattern is particularly useful in scenarios where you need to create objects based on certain conditions and configurations, but you want to avoid exposing the object creation details to the client code. To implement a factory pattern, it requires 1. A factory class responsible to create a concrete product. The create function call usually takes an input to indicate what requirements are needed. 2. A product interface to represent the concrete products. It also defines a list of common function calls among all concrete products. 3. A set of concrete products that implement the product interface. 4. Finally, a client code that interacts with the object created by the factory. Decorator pattern. The decorator pattern allows you to add new behaviors to objects dynamically without altering their existing structure. It involves creating a set of decorator classes that are used to wrap concrete components, enhancing their functionality. The decorator pattern follows the open-closed principle, which means you can add new functionalities without modifying the existing components. It is particularly useful when you have a class that needs to have multiple optional behaviors that can be combined in different ways. Common use cases include encryption, enhanced logging, or formatting to objects. To implement a decorator pattern, it requires 1. A component interface that carries a component abstract method. This method will be implemented by the concrete component class and the concrete decorator class. 2. A concrete component class that represents the core object. 3. A decorator interface that contains a reference of a component object and it has to implement the component interface. 4. A set of concrete decorator classes that implements the decorator interfaces. 5. Finally, the component can be enhanced with different decorator in the client code without modifying the component object itself. Observer pattern. The observer pattern defines a one-to-many dependency between objects. In this pattern, when a subject undergoes a change in state, all its observers are notified and updated automatically. It is used to establish a loosely coupled relationship between objects, where the subject informs multiple other observers about its state changes without them needing to be tightly coupled. Common use cases include event handling in a system or IoT sensor applications. To implement an observer pattern, it requires 1. The subject is the object that maintains a list of its observers and notifies them of state changes. It usually comes with registration and unregistration methods that the observers can register or unregister themselves with the subject to be notified of changes. 2. Observers that are interested in the state of the subject. They will register with the subject to receive updates. 3. A notification from a subject that notifies all registered observers by calling a method on each observer. Adapter pattern. The adapter pattern allows you to make two incompatible interfaces work together. This pattern is particularly useful when you want to use an existing class that doesn't quite fit your needs, but you can't modify its source code. Here's how the adapter pattern works. A target interface that your client code expects to work with. An adaptee is an existing class that is not compatible with the target interface. An adapter class that acts as a bridge between the target interface and the adaptee. It implements the target interface and delegates the calls to the adaptee in a way that makes them compatible. Design patterns are the building blocks of great software. If you found this video useful, please like and subscribe for more programming tips and tutorials. Your support is appreciated, and remember, good design is the key to successful coding. Thanks for watching.